Hi, my name is Mirta Lucas and this is a video for homework 2 in the class CSE 578. We were asked to implement, number one, we were asked to implement the cost functions for the gross entropy and log likelihood, and quadratic cost was already provided. Here is my gross entropy implementation and here is my log likelihood implementation. And notice that the gross entropy, even though was provided, the function, I changed a little bit in order to avoid non-values. Similarly, in the derivative, I avoid the division by 0. The same way happened in log likelihood. We were also asked to implement activation functions for tangent, hyperbolic, ReLU, and softmax. Sigmoid was already provided. Here's the provided one, and this is the implementation for tangent, ReLU, and softmax. We were also asked to implement the regularization functions using L1 and L2. The implementation functions for L1 and L2 was included in the functions total cost. Here's L1, L2. And the derivative of those L1 and L2 was included in the update of the mini batch. Where the weights are being updated. Here is L1. In the case of L1, this is the code. In the case L2, and in the case that there is no L1 by default, not L1, not L2. We were also asked to implement the dropout functionality, and the idea was to remove a percentage of neurons in each hidden layer. Dropout was not using input or output layers. The implementation of the dropout functionality consisted of initialization of the dropout extractor to keep track of the neurons dropped in each layer. And that was done in the init function. Here, I'm setting up the used extractor, setting with zeros. And next, it was the use extractor was filled with 0 or 1 depending on the dropout percentage using a binomial random selection. Here it is. Here notice that I'm not setting up anything in the input or the output, but I am placing information in the hidden layers for the neurons that are going to be dropped. But the final usage of the used extractor or the zeros or ones in that extractor is included in the backpropagation function. Where here, notice that it's being used in the feed forward and it's also used in the backward in order to ignore the errors of the neurons that are removed with the dropout functionality. We were also asked to modify the functions of feed forward. And the idea was to consider if this was an output layer or a hidden layer in order to use the corresponding activation function. We were also asked to modify the backprop function. And it was a similar situation. We're using input or output layer, but I also modified the backprop to include my dropout functionality. We were also asked to modify the update mini batch, and the update mini batch was modified to include regularization functions for L1 and L2. And I also modified this function in order to include my dropout functionality. We were also asked to modify the total cost, and that was for L1 and L2, and the set parameters. And that was at the time of including the activation functions for the activations for input and output, input and hidden layers. And we also included to modify the activation output if the tangential, hyperbolic, and a different function cost was different of quadratic. It was set to sigmoid. Finally, I performed all the tests that Dr. Tomuro asked, and these are my results. I also included the extra test that she requested. Thank you.